Hey, this is Chad with GeoPro. I'm going to do a quick tutorial video for Noel and the guys to see if we can process some data that they sent me. So what we have here is 3 days worth of data, GPS and DC files, and in the background a blank TBC project. So we'll start back here. I'm going to change the coordinate system. Guys are working in UTM, 51 north. EGM 08 is a geoid model. Reference to WGS 84. We'll hit finish here. And then we should be ready to start importing data. So day one, GPS files, we'll start there. Home and import, and then I can paste that directory right there, then import in the files. So if I sort by point ID, I've got some 2000s, which are temporary points, some 4000s. So I go through. Let's sort by duration. See if we can find the base here. So 3 seconds. If I sort the other way, I got 2 points here, default and default. One of them is a 4 and a 47, the other's 301. I'm guessing this is your base station. So I'm going to change the label to 1000. And I'm going to send one of them to RTX. I want to check the antenna tab also. Okay, on here, everything looks good. They should all be to bottom of antenna mount. So you've got one that isn't that way. It looks like the two bases. Bottom of antenna mount, and they should all be 2 meters. So you're using a 2-meter rod. So otherwise, everything looks good. You just want to make sure that your antennas are set up. Bottom of antenna mount, 2 meter. Receiver, hit OK. Now it's going to upload those base files, which are pretty large, up to the internet. And it's doing that now. When you upload it to the internet, it's going to process against some base stations, and then it'll give you a good solution. Some old data in here. So right now it's uploading the data, that base station file, up to the internet, and it's processing it. So here we have the first day of data. You got 1,000 point, a few GPS shots. Also got some stuff out here I don't understand. Looks like maybe the base shut down or something weird happened here, because you've got points out there, but you don't have vectors, which indicates that the rover was running and the base wasn't. So we should have lines out to there. So after it's done, you can hit import. This will bring in good coordinates in for 1000. And now if we look at point 1000, there's an RTX solution. Right click, say properties, and we're going to set that to control quality. Reprocess. And now suddenly this 1000 has good coordinates to it. So we can close that. While we're doing it, let's import in the rest of the data. So day one, we're going to bring in the DC file. If it asks, we're going to keep working in. When you guys set up in the field your data collector definition for the coordinate system, that's slightly different than what we set up here at the beginning. You can do either one. You can keep the existing, or you can convert. It's not going to make a difference. It's going to ask, okay, there's a lot of GPS points in here. They exist in the GPS data, and they exist in the total station file. It asks if you want to merge those, and we'll say yes. So you can see here, you guys sat on some points, like 2004, you've got a GPS vector going into it, and then total station observations coming out of it. So this is how it's supposed to look. Looks good there. So let's import in the rest of the data. Day two, GPS files. check the antennas. Okay, everything looks right there. Import those. We'll import in the DC file from day 2. Again, similar points. And then finally day 3. And the total station data from day 3. So here you have the project. Everything brought in. You can see that your GPS base station 1000 was running. You've got a lot of unprocessed vectors here at various points. And up here, again, you set total station. I'm not sure why, but there aren't GPS files into this. So you should see these unprocessed vectors to 2000 and 2001. So that looks like a problem. But let's go ahead and we will process this data. Gives us some computational warnings here. Ideally, these wouldn't show up, but we'll go ahead and hit yes and continue. I bet these are related to the fact that, again, this looks suspicious. It looks like what happened was that the base station was running in the morning. You guys did some GPS shots, collected data with the rover, and then at some point the base shut down. And because of that, then you keep measuring shots. And so we don't have those GPS vectors here. So these coordinates are floating. They're not going to be very good. They'll be plus or minus probably 15 meters or so. So the data is processing here. If you sort it by solution, you can see ones that have failed. What does that warning say? No valid overlap data could be found. So it looks like, yeah, maybe that base shut down for some of this. It's all done. We can hit save. So there's a few flags here. We can look at point 2006, for example, and say, show me the point derivation report. And it looks like you sat on 2005, you backsighted 2006. The horizontal positions matched really good, but there was something in the vertical. It looks like maybe that rod height was off. Could be a result of the GPS being a little questionable. Here, let's check this one real quick. Point derivation report. Again, there's a slight vertical issue here, so you guys want to make sure that when you're entering that rod height that you're not putting in 2 meters here. And I can actually check this if I look at your total station observation. .236. That seems like the right raw target height. So I'm not sure what's going on there, but it could be a result. Let's do this. Let's check, grab everything, select everything, and then look under the view at the Google Earth tab. And we'll hit that. I just want to export everything out, make sure we're in the right location. Make sure I didn't make any other mistakes. Okay, so yeah, so here's your 1000. Just looking at it, there's some big trees there. I'm not sure if those are still there or not, but it might have been affecting the GPS a little bit. But down here, okay, so down here you shot this end of runway, and there aren't GPS vectors into here. So this end of runway is not going to have a good coordinate. Let's see the other end. Okay, so 3500 here, the O2 end, has these GPS vectors. So this is going to be a good position. And then it looks like you shot a few obstructions over in here. So center line points. So it's a good start to the data. If we look at, let's go back over here. Let's look at 0.3000 and 3500. So if we look at the properties of it, 3500 has an elevation of 4 meters. If we go over to the 3000, it's about 4 meters too. So maybe that's somewhat accurate. I don't know. But you've also got some data in here that has some unknowns to it. Antenna terminal. .176. So it's hard to know where that's coming from, but there's a consistent vertical error here, it seems. Sometimes it's 3 decimeters, sometimes it's 1.5, but there's something slightly off there. But otherwise, the other data kind of looks good. You can see you've got some intersection points out here. You've got some obstructions that you shot close in. So it's a good start to the data. What we want to do now is export out the coordinates that we really want for the Aerodat program. So let's start with points 3500 and 3000. On the Home tab, we can say Export and export out point northing, easting, elevation, and code. We'll call this runway. Runway ends. Hit save and then export. Then let's see. Basically everything else we got. We'll just do these points, for example. These 9000s. So I can select them. Now, if I wanted, I could select everything. For example, you guys have some more obstructions down here. We're going to export these out. As obstacles. Now,